Outliers are really important. So whenever we do exploratory data analysis, we look for outliers. We identify them and then we try to work out what they mean. Sometimes outliers will exist because there was some problem in the measurement, in the collection of the data. There might be something wrong with a sensor. There might have been a bug in a computer program. Sometimes the outliers are there because data was recorded incorrectly, or maybe something went wrong in a spreadsheet in some intermediate processing step. But sometimes they're there because there's something interesting going on in the data that we ought to know about. It could be that there's some significant change happening in a process, for example. In the case of student marks, sometimes there are a few outliers at the high end, exceptionally high marks, and there can be various reasons for that. But most commonly, outliers occur at the lower end, and they nearly always occur because there are some students who don't submit all of the assessments, and so they get unusually low marks, typically fail the course. So how do we identify them? Well, there's a method that has been pretty standard in exploratory data analysis, and I'm going to explain to you now how that works. This is a method that is just used with single quantitative variables. There are some very sophisticated techniques that are used for much more complicated data sets, but we won't be going into those. So what we have to do to calculate or to identify outliers is we've got to calculate two further statistics called the lower fence and the upper fence. And this is the only thing we use the lower fence and the upper fence for. They're just to identify outliers. So to calculate the lower fence, what we do is we first calculate the interquartile range. So I hope you recall that is Q3 minus Q1. That's the middle half of the sorted data. So in the case of our marks data, that was 9. And we multiply that by 1.5 and we subtract that from Q1. So in our case, that gives us a lower fence of 49, where are we? Sorry, 49.5. The upper fence is calculated in a similar way, so it's the interquartile range of 9 multiplied by 1.5, but this time we add that to Q3, to the upper quartile, and that gives us an upper fence of 85.5. So now we can see the 5 numbers and the fences. So this is our sort of full set of calculations that we do when we first get a quantitative variable to try and understand it, to get a picture of it. So in our marks data set, what we're looking for is outliers. And there are two types of outliers. There are data points that are smaller than the lower fence, or data points that are bigger than the upper fence. So the analogy here really is you can think of outliers as being, goats who jumped the fences. Now, with the marks data, the lower fence, 49.5, is lower than the lowest mark. The lowest mark is 53. So there's no lower end outliers in last year's course. No goats jumped the lower fence. But at the upper end, there are some outliers because the upper fence is less than the maximum. So there must be some outliers at the high end. In fact, there are 9 outliers. So 2 students got a mark of 87, which is bigger than the upper fence. 1 student got 89, and then what is it? 6 students got 92. So I've added them to our little visualization here, and if you look at that, I've put the outliers there as little pink circles. And what I've done with them is something that we fairly commonly do in this situation. I've done what's called jittering. I've added a little bit of vertical space to them so that you can actually see that there are 9 outliers, because if I didn't do that, they'd all sit on top of each other and it would just look like there were 3 outliers. So occasionally you'll see when I prepare a diagram, I will have done a bit of jittering, and I'll generally will tell you if I've done that. Okay, so the fences themselves, one of them is, where are they? So one of them's at 49.5, so that's, I don't know, somewhere about there. And, oopsie daisy. The other one was, what was it? The upper fence was, I've lost it, I've forgotten. 85.5. Okay, so 85.5 is going to be, I don't know, somewhere around there. So that's roughly where the fences are. So when we do what's called the 5-number summary, if I asked you, for example, to do a 5-number summary of some data, that's what I'd be looking for really, is n. We nearly always report the size of the variable, the length of the variable, and then the minimum, the median, the maximum, and the lower hinge, Q1 and Q3. And then if there's a small number of outliers, we just list them. If there's a large number, you just say there's a large number of upper outliers or lower outliers or something like that. But that's essentially what we're looking for. So this is the kind of basic set of information that we get in the first step of exploratory data analysis when we're looking at a single variable. We don't normally report the upper fence or the lower fence. Now, what we're going to see in class in the second lecture is I'm going to show you how we turn this data into a graphic called a box plot. And that is the fundamental first visualization that we do when we're doing exploratory data analysis with a quantitative variable. It's not too dissimilar to what I've done there, but it is a little different. And once you learn to use box plots, you'll find you can do lots of quite interesting things with them, and they convey quite a lot of information, but you have to get familiar with them. They're a spatial representation, and you have to get used to the kind of spatial thinking that goes with that. All right, thank you.